Good morning. In this presentation, we will be examining a fundamental concept within compiler design, the follow set. Let us begin by developing a clear understanding of what the follow set represents and why it is a critical component. The formal definition states that the follow set for a non-terminal, which we can call X, consists of all terminal symbols that can immediately succeed X in any valid sentential form. A special consideration is the start symbol. The end of input marker, denoted by the $, is always included in the follow set of the grammar start symbol. Intuitively, this set simply tells us what symbols can appear right after a non-terminal. Its key objective is to determine the proper context for these non-terminals, which is crucial for making predictive parsing decisions and for effective error recovery. Now, let's discuss the first two rules for computing this set. Rule 1 concerns the start symbol. If X is the start symbol of the grammar, the $sign is directly added to its follow set to represent the end of the input. The rationale is that the end of input marker logically follows the completion of the entire derivation. Rule 2 involves a terminal successor. If a production has the form A produces alpha X a beta, where A is a terminal symbol, then A is added to the follow of X. For example, given the production S produces AB, the terminal B follows A, so B is included in the follow of A. Next are rules 3 and 4. Rule 3 applies to a non-terminal follower. For a production A produces alpha XB, where B is a non-terminal, we add all non-silent symbols from the first of B into the follow of X. There is an important condition: if the first of B includes epsilon, then all symbols in the follow of A must also be added to the follow of X, accounting for B's potential disappearance. Rule 4 covers the end of a production. If a rule is A produces alpha X, where X is the final symbol, then everything in the follow of A is added to the follow of X. This is an inheritance mechanism, ensuring X receives the contextual symbols of its parent non-terminal, A. To illustrate, let's consider a simple grammar specified by the productions S produces AB and A produces either A or epsilon. Applying Rule 1, since S is the start symbol, its follow set, follow of S, is initialized with the $sign. Next, we apply Rule 2 to the production S produces AB. Here, the terminal B directly follows the non-terminal A. Consequently, the terminal B is added to the follow set of A, making the follow of A equal to the set containing B. In summary, it is important to distinguish between two concepts. The first set defines all possible terminals that can start a derivation from a non-terminal. In contrast, the follow set identifies terminals that can immediately succeed a non-terminal in a valid string. The accurate computation of both first and follow sets is not just theoretical. It is absolutely fundamental for constructing the predictive LL of one parsing tables that are required to enable top-down parsing.